Welcome to the first installment of the Flipped Classroom. Today we're going to talk about chemical reactions, what they are, what they look like, how we can find evidence of them, and then how we display a chemical reaction with our chemical equations. You want to make sure that you're taking Cornell notes over this video. I'll give you instructions on Friday where we're going to put these notes in your notebook and get it started as the second 6 weeks of the school year. Okay, so here we go. So, a chemical reaction is a change in matter that produces one or more new substances. We see chemical reactions every day. We just don't identify them as chemical reactions. There's 4 signs or indicators that a chemical reaction has taken place. One of the most common signs is the formation of a gas. You guys have done this lab in the past where you have vinegar and baking soda and you mix them together and you have all this bubbling and fizzing. That's the formation of gas. The gas is the new substance. The second sign is the formation of a precipitate. We're going to see this in class as a demonstration, but basically you end up combining 2 liquids and the formation of a solid occurs, and that solid is a kind of powdery substance that falls to the bottom of the new liquid. This powder is the new substance that's formed from the reaction. You can also have a color change, that's the 4th indicator, and then a temperature change. You need to be careful with color change and temperature change. A color change can occur without a chemical reaction taking place. A temperature change can occur without a chemical reaction taking place. Let me give you my example. If I have an ice cube and I sit it in my hand and I allow it to melt, the ice cube will change temperature. It'll go from below freezing to room temperature usually. In this instance though, the chemical substance in my hand is still water. The atoms didn't rearrange, there's no change, and all that's changed is the temperature. That is not a chemical change. Okay, so chemical reactions occur when different atoms and molecules combine together and split apart. Atoms are rearranged in the way they are connected or bonded. They are not created or destroyed, and we'll talk about what that means in a minute. There is a difference between a chemical reaction and a physical reaction. In a physical reaction, the change affects the size, shape, or color of a substance, but does not affect its composition, so no new substance is formed. So a lot of times our changes in states of matter, melting, boiling, evaporation, freezing, those are all physical changes, not chemical changes. A chemical reaction is a change caused by the rearrangement of atoms of one or more substances, resulting in the formation of a new substance having entirely different properties. And we're going to be seeing this next week when we do our labs. Okay, there's a law out there, it's called the law of conservation of mass. What this law tells us is that matter cannot be created nor destroyed. So, in a chemical change or reaction, all the atoms that go into the reaction as reactants will come out as products. So, into the reaction to create H2O, we have hydrogen and oxygen that go into that reaction. As a product, H2O is created. Remember in class I mentioned that hydrogen is very explosive and oxygen is necessary for fire to keep going. But when you have the chemical reaction that causes water to be created, H2O, you get a substance that is neither explosive nor allows fire to keep going. We talked earlier about temperature change being an indicator of a chemical reaction. Well, there's 2 types of chemical reactions that involve temperature change, and they are called endothermic and exothermic. When reactions absorb energy, they are called endothermic. So they're absorbing the energy into the reaction, and you'll actually feel the temperature getting colder of the substance. When reactions release energy, they're called exothermic. And what ends up happening is the reaction will cause the temperature to get hotter. Okay. So let's talk about how we show chemical reactions. When we're showing a chemical reaction, we need to write an equation. And up here you have an example of an equation. 4Al reacts with 3O2, yielding 2Al2O3, okay? Aluminum oxide. So basically, equations are used to describe what happens in a chemical reaction. In this reaction, aluminum reacts with oxygen to form aluminum oxide. We have to make sure that our equations satisfy the law of conservation of mass. So in order to do that, we have to count the atoms on the reactant side of the arrow, which is everything in front of the arrow or to the left. And we have to make sure that we know how many aluminum atoms we have, how many oxygen atoms we have. We have 4 aluminum on the reactants. We have 6 oxygen on the reactant side. Then we count our atoms on the product side. And in this case, we again have 4 aluminum and 6 oxygen. When the products and the reactant matches up like that, we have the same number of atoms on each side, we know that our equation is correct. It's what we call a balanced equation, and it satisfies the law of conservation of mass. All of the matter or mass that went into the reaction, every atom of aluminum, every atom of oxygen that went into the reaction came out of the reaction. The atoms were just rearranged and formed a new substance. I hope you enjoyed this first video, although we had some background noise and such. But make sure you have your Cornell notes, summarize them. All of this is due on Friday, so if you have any problems, just let me know. Have a great evening.